Hey there, geometry class. I want to, I know you just took a quiz and you're ready to do more. So this is lecture 6.4 about special parallelograms, which are rectangles, rhombi, plural of rhombus, and squares. Before we talked about the various theorems and components that go with parallelograms, of course, by definition, parallelograms are made up of opposite parallel sides, or two sets of parallel sides. So when we think about their angles, right, we think about their consecutive angles being supplementary and their opposite angles are congruent. When we think about the sides, the opposite sides are congruent. And when we think about their diagonals are bisected. Well, what's so interesting about these special parallelograms, rectangles, rhombi, and squares, is they have all of these properties and more. And so part of the theorems you had to do was get these properties of rectangles and rhombuses, rhombi, in your notes. And what I want to do is take this information and compile it into one table. And I think you should make this table and follow along with me. So I'm going to pull off a term here. And it says congruent. Well, in a rhombus, all the sides are congruent. It has all the properties of a parallelogram. Opposite sides are congruent. But now we're saying all the sides are congruent. What else do we have in my mystery set of things here? Bisected. Oh, this is interesting. In a rhombus, the diagonals bisect the opposite pair of angles. So not only are opposite angles congruent, but they're bisected. What else? Bisected again. Well, in case you didn't know this, a square is both a rhombus and a rectangle. All right, what's my next term in here? I have another congruent. Oh, well, in a rectangle, the diagonals are congruent. All right, what else? Perpendicular. Oh, yeah, in a rhombus, the diagonals are perpendicular. They're at 90-degree angles, which means in a square, they're perpendicular as well. You can kind of see how this is playing out. Here's another congruent. All right, in a square, the diagonals are perpendicular and congruent. In a rectangle, all the angles are congruent. Well, if they're all congruent, what do they have to be? They all have to be right angles. So let's see, what am I missing here? All right, I think I'm down to just right and right. There we go, right and right. So check this out. Here's my brand new table. In a rectangle, all the angles are congruent and all the angles are right. Their diagonals are also congruent. Now, in a rhombus, the opposite angles are bisected and all the sides are congruent and the diagonals are perpendicular. And a square is both a rectangle and a rhombus. Great. You got all this information. You've recorded that, you've paused the video, you've gone back, you've collected everything you need. Now let's make some sense of this. It says TVWX is a rhombus. Okay? That means all those properties of rhombi, the opposite angles are bisected, the sides are congruent, the diagonals are perpendicular. Those things are true, as well as all the properties of parallelograms, because a rhombus is a parallelogram. So when it says find TV, TV is this side length, right? How are you going to find out what TV is? Well, interestingly enough, I know that WV is XT. So I know these sides are the same. In fact, all four sides have to be the same. And that's the beautiful thing, because once you find one side, you know that all four sides have to be the same. So this problem just got a little bit easier. Once you recognize that all four sides are the same, you can go ahead and set up and solve. All right, when you substitute b into 13b minus 9, you get TV, or any side, is equal to 7.9. The next problem here, it says, show that the diagonals of a square are congruent, perpendicular bisectors of each other. So don't panic when you see this kind of problem. Just take a deep breath and read it one more time. Show that the diagonals of square EFGH are congruent, perpendicular bisectors of each other. Well, in order to show that the diagonals are congruent, right, find their length. So step 1, show that EG and FH are congruent. So let me just use a little tool here. So I'm going this one here to this one here. And again, what I'm doing is 1 squared plus 7 squared, right, is 50, and I'm taking the square root of 50. So I know this one here is the square root of 50, and when I go from here to here, again, I'm going up 1, and then this is Pythagorean theorem, up 1, 1 squared, over 7, 7 squared, 1 plus 49 is 50, the square root of 50. I have now shown that both diagonals have a length of the square root of 50, and that makes them congruent. Now, step 1, complete. Step 2, show that they're perpendicular. Well, that means the slopes have to be opposite reciprocals. So when I pull, actually let me just delete that. Whoa, much better. When I look at the slope, right, I'm going up 1 over 7, check. Here I'm going down 7 over 1, so that slope is just -7. Therefore, I know that the slopes are indeed perpendicular. Now the proof. So again, we still have just a couple more proofs, and really this is the last slide in this lecture. I'll try to keep it under 8 minutes. It says, given PQTS is a rhombus, so that's a rhombus, which means all 4 sides are congruent, and it's a parallelogram, and all those other properties are there. Prove that RQ up here is congruent to RS, right? So again, you start with your given information, statements and reasons. Here's my given information. Now, this is labeled showing it's already congruent, and you actually need to, by the definition of a rhombus, show that. Okay, so keep that in mind. You have to show that. It's not just given, it just says it's a rhombus. But the other thing is the diagonal bisects these angles right here. And that is really important. And that's what they're showing you in steps 2 and 3. It says, okay, PT bisects QPS, right? And therefore, the definition of a bisector means those 2 angles are congruent. Well, great. Now I know this angle's congruent, this angle's congruent. I'm sorry, this angle, that side, this side. And I know PR is also congruent to itself by the reflexive property. Therefore, I know that these 2 triangles, QPR is congruent to SPR, and according to, you guessed it, CPCTC, this side here, RQ, is congruent to RS. Guess what? That's it for now. Short lecture. Here's what I want you to do. You've got 15 problems from section 6.4, and a lot of them are just identifying the properties. Does it have to be a square? Does it have to be a rectangle? Does it have to be a parallelogram? Please check these problems as you go. If you have some extra time, of course, how's your Khan Academy doing? That February, I think it's February 6th, is coming up really fast. Now here's your homework. After you complete this, here's your homework. I want you to watch the next lecture, 6.5, and do the problems. There's 3 problems in there that I don't give you the solutions for. And we'll go over that, and we'll go over this in class the next time we meet.